Lesson 2, Graphing Linear Inequalities. This is Unit 8. Using the graph pictured above, answer the following. What are the coordinates of the y-intercept? So the y-intercept is where the graph hits the y-axis, and I can see that it hits the y-axis right here at a -3. So the coordinates of that point is 0, comma, -3. What is the slope of the line? If I go from this point, the y-intercept, to this point here, I'm going to count up 2 and over to the right 1. So 2 over 1 is the slope, and then 2 divided by 1 is just 2. Write the equation of the line. So the equation is y is equal to the slope 2 times x minus 3, the y-intercept. On the grid above, draw a line parallel to the given line. It's hard for me to draw lines on this. I'm going to try and construct it using a tool. Well, I have a line that's parallel. That's the best I can do right here. So the equation for this line, it's still going to have the same slope because parallel lines have the same slope. Okay, so I'm going to take that slope. I'm going to keep it, but I have a new y-intercept of -6. So that's the equation of a line that I drew that is parallel to the one that's provided in the graph. So with regard to slope, we have two forms of formulas for a line. One is slope-intercept form of a line, which I just used. Y is equal to mx plus b. And point-slope form is the change of y is equal to the slope times the change of x. And you would use this if you are given 2 points. And you also have to keep in mind or know the slope formula. So if you're given 2 points and you need to find the slope, it's the change of y over the change of x. So those are 3 formulas you got to remember. Okay, so we want to solve this following systems of equations graphically. So the first thing I need to make sure is that both equations are in terms of y. This bottom one is not, so I'm going to subtract the 2 from both sides and get it equal to y is equal to. This is my y-intercept, and this is my slope, -3. So the y-intercept of the first equation is 8, and the y-intercept is -3. So I'm going to go to the y-axis, go up to 8, put a little dot there, and I'm going to go down 3 over 1. So I'm applying the slope, down 3 over 1, down 3 over 1. You only need 2 points to graph a line. I have more than that, so I'm pretty good to go. As you know, I have a hard time drawing lines on here perfectly, so I'm going to have to do it without a straight edge, but you by all means use a straight edge to construct your line. Okay, now for the second one. I'm going to construct that in blue. So the y-intercept is a -2. It's right here. And I'm going to apply the slope of up 1 over to the right 3. And there's the point of intersection, right where the blue overlaps the red. Okay, and there's my next line. So 3, -1 is the point of intersection. That's the solution for both of these equations, because that's what happens when we have a system of equations. We're looking for a common solution. It's the point of intersection. And you must label it. So we just solved this graphically. So when you're graphing linear inequalities, you have some rules to follow. And as you can see, you have some inequality signs. And because there's no equal sign on the first two, the type of line that gets constructed is a dashed line. And this is hard to remember. And because it's less than, the shading is beneath or below the line. Okay, the greater than symbol is also a dashed line. I'm putting these quotation marks. That means repeat what was stated above, dashed line. And the shading is above the line because it's greater than. Okay, so now we have the equal sign here. That means we have solid lines. And for less than or equal to, shading is below the line. And greater than or equal to, shading is above the line. Okay, so we're asked to graph these inequalities. All values for x are less than 2. So let's pretend that x is equal to 2. So that's on the x-axis right here. We're going to draw a dashed line because there's no equal sign in the inequality. And all values for x that are less than are all shaded this way. So values for y that are greater than or equal to 3 over 2, x minus 5. Minus 5 is the y-intercept. It is a solid line because of the equal sign in the inequality. So I'm going to start with the y-intercept and I'm going to apply the slope of 3 over 2. So up 3, over to the right 2. Up 3, over to the right 2. Up 3, over to the right 2. And then you connect the points, use a straight edge. And all values for y are above this line. So shading is up here. So for the first inequality, I'm going to start with its y-intercept of 1. And I'm going to apply the slope of up 2 over 1, up 2 over 1. It's a dashed line. And all values for y are less than, so it's below the line. For the second inequality, I'm going to start with the y-intercept of -2 and apply the slope of -3, so that's down 3 over to the right 1, down 3 over to the right 1. That is a solid line because the inequality does have an equal sign. And all values for y are higher than that line, so that's above the line. So where we have this cross-hatching here is the common solution set. So we're being asked, is negative 2, 4 in the solution set? So let's locate that. Negative 2, 4, 1, 2, 3, 4. No, it is not. It only fits the profile of one inequality, and that's the second one. You need the solution to be in the common solution cross-hatched area, this area or region in here. Is 1, 3 in the solution set? So 1, 1, 2, and 3. It is not in the solution set, although it appears as though it may. Then the reason as to why it is not is because the first inequality, the blue dashed line, is not including that value. So it's not in the common solution set. So the answers to both of these are no. The region is the intersection of how many half-planes? Explain how you know. Well, it's two half-planes. And the reason that I know is because each inequality splits the plane in one half. Shading for the inequality without the equal sign is below the intersection, and the shading for the inequality with the equal sign is above the intersection.